So in this video, we are gonna see a problem based on definition of Jacobian functions. So here, u1, u2 and u3 is given in terms of x1, x2 and x1, x2, x3 respectively. And we have to prove that dou u1, u2, u3 by dou x1, x2, x3, that is Jacobian of u1, u2, u3 with respect to x1, x2, x3 is equal to dou u1 by dou x1, dou u2 by dou x2 and dou u3 by dou x3. And hence we have to prove one more result where x, y and z is given. So let's start with the first proof. So here dou u1, u2, u3 with respect to x1, x2, x3 is being asked. Now we all know the value of this is a determinant of order 3 by 3. So let's draw it. So now let's find out the values of each and every term. So here to find dou u1 by dou x1, I'll use the function. Now since u1 is function of x1, I'll get value of dou u1 by dou x1, but dou u1 by dou x2 and dou u1 by dou x3 will be 0 since in this function there is no term such as x2 and x3. So the first row will become dou u1 by dou x1 0 and 0. Now let's see u2. Since u2 is function of x1 and x2, here we'll get the values for dou u2 by dou x1 and dou u2 by dou x2, but we'll get dou u2 by dou x3 as 0. Now let's see u3. u3 is function of x1, x2 and x3. Hence we'll get all three values in the last row. So this is the new determinant. Now we have to solve this determinant. If I'll solve this, so here after solving the determinant, we are getting value as dou u1 by dou x1, dou u2 by dou x2 and dou u3 by dou x3. Hence proved. Now let's find the deduction. Here we have to find out value of Jacobian of x, y, z with respect to u, v, w. So to find that, we will use the result which we have proved here. Now since we are saying that dou u1, u2, u3 by dou x1, x2, x3 is dou u1 by dou x1, dou u2 by dou x2 and dou u3 by dou x3. So I'll say that this dou of x, y, z by dou of u, v, w will become dou x by dou u, dou y by dou v and dou z by dou w. So here I am taking the reference of the result which we have proved. Now let's find the value of each and every term. So to find the value of dou x by dou u, I will use the value of x. Now here x is cos u. So dou x by dou u will become minus sin u. Similarly, to find value of dou y by dou v, I will use y. So y is cos v sin u. Now I want to differentiate this y with respect to v partially. So hence sin u will be constant and the derivative of cos v is again minus sin v. So that will become minus of sin v. Next, to find dou z by dou w, I'll differentiate this z with respect to w partially. Hence sin u and sin v are constant. So as it is sin u and sin v, and derivative of cos w is minus of sin w. So hence we get this minus 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 will become minus, sin u term 3 times, that will become sin cube u, this sin v term 2 times, so we'll get sin square v, and the sine w term is only once, so we'll get sine w. Hence, the value of Jacobian of xyz with respect to UVW is minus of sine cube u sine square v into sine w. Thank you.